Thank you for picking this talk this morning with such a capacity crowd, and I do think it's absolutely worth your time. It's also absolutely worth my time because this talk has been, I think, a year in the making. I'll be talking about the OWASP Top 10 2017, and if you have followed that top 10 list created and curated by the Open Web Application Security Project, OWASP, then you may have seen that, there was a list in 2003 and then one in 2004, 2007, 2010, 2013. So you kind of see a pattern here, right? At last year's conference, we thought about how about we do a session on OWASP Top 10 2016. I said, awesome idea, let's do that. And then we waited and waited and waited, and then we did something else, of course. And we wanted to do this then in London at the London show in January. Still no list, okay? But now we are lucky because a couple weeks back, release candidate 1 of the OWASP Top 10 2017 was released. So actually there is something to talk about. Now, basically, the top 10 list of the OWASP is a list not of security vulnerabilities, that's a misconception, it's a list of security risks, right? So things that might happen, and it just provides a good overview of what kind of risks are out there for today's web applications and how to mitigate those risks. There have been some discussions, recently and also since a while, whether this list is still relevant. Because how is this list assembled? Basically, security researchers, they anonymize the results of their audits and they put it into a system. So if they have found, a certain risk that many times and another risk that many times, it's put in. And in the end, the people responsible at OWASP for that list, they kind of do the math, try to categorize everything, and then put out a top 10 list. Now, if we go through that list, some of those items on the list, they seem to be at the wrong position, right? At least in my opinion. Some of those items, they are kind of really weird. So you can really argue, is this list still relevant today, right? But I think it still is, because so many people, so many developers are now moving to web development. And everyone needs to know about security. It's such an important topic. So everyone has to know what risks exist and how to work with these risks. And therefore, this list, even though if I don't always agree with some of the items on the list or the ordering of that list, is still a very valuable asset. So what I would like to do today, this morning, is I'd like to go over that list. We'll have a look at the 10 items on the list. I'll cover each of those items. For some of them, we have a look at code or we have a look at countermeasures. And also there are some maybe attacks that kind of do not fit in one of those 10 items. So I've added them where I saw them fit as well. So in the end, you should have a very good understanding of what to look out for when talking about web security. Both old and, trusted risks and vulnerabilities on also rather novel attacks. So that's the agenda for today. And talk about agenda. Basically, that is the agenda. That's the 2017 top 10 list as of release candidate 1. I expect the final version to be released in fall, but the order of the risks and also the names of the risks, I think they should not change. So we have injection, broken authentication and session management, cross-site scripting, and these 3 items actually, they are the same items as in the previous list. And then there's some subtle changes. Broken access control, that's kind of new. Security misconfiguration, that's old. Sensitive data exposure, old. Insufficient attack protection. Okay, that sounds a bit weird. We need to talk about that in a bit. That's kind of new. Cross-site request forgery, that's old. Using components with known vulnerabilities, that's old. And very new, and a new word which I didn't find in Webster's dictionary, under-protected APIs. So let's have a look at those 10, and let's start at number 1. And number 1 is a thing that I find a bit weird. I mean, I do web development since about 20 years now, so I started really early. And back in the heydays, there was a lot of injection. Well, I mean, there are different kinds of injections, right? So LDAP injection, for instance, XPath injection, or a thing I kind of invented for a small paper I once wrote, and then I later found it in an audit about a year later. Talk about the inside, regex injection. So the idea, of course, is we get input from the user, and that input is then put into, well, a kind of a query language most of the time, right? Since many query languages do not, or put both commands and data in the same, well, string, we might get an injection. So a malicious user could inject a kind of command into our query string. Now, when we talk about injection, I would say over 99% of instances where we do find injection is SQL injection, right? And yes, in the 1990s, SQL injection was the thing. And in the early 2000s, SQL injection was the thing. Well, injection is still #1 on that list. That's interesting. Maybe because I find it so confusing, let's have a look at that list. So what you get as part of that list is a nicely formatted PDF where for each and every item on the list, you get information, countermeasures, etc., and you get this kind of matrix. And you get both, you get like a colored scheme. So how easy is it to well, attack this risk? How easy it is to exploit that? And SQL injection is easy to exploit, and the impact is severe. And because of, you know, those two red flags here, maybe that's why it's so so far on top of that list. But I mean, seriously, those of you who work with web application security or have followed web application security over the years. I mean, how often do you see SQL injection or SQL injection today or in the last few weeks, months, years? Seriously, I mean, I regularly do audits, and SQL injection is usually the least of my concerns, because how do we communicate with a database these days? I mean, if you're using .NET, and I think the majority of you are doing that, then Microsoft is kind of forcing us, more or less, to use Entity Framework. With recent versions of Entity Framework, it's extremely hard to create SQL injection, because it's extremely hard to, you know, actually send commands to the database. And the idea of object relational mapping is that you do not use SQL any longer anyway, because you work with objects, right? And Entity Framework in that case does the mapping. And if you use something else like nhibernate, or if we are not in the .NET space, Hibernate or Propel or whatever, well, then the framework takes care of that. So really, SQL injection, I haven't seen this in quite a while. I do know that there are many instances of SQL injection out there, old legacy applications that were written in, let's say, classic ASP, and are still running somewhere. I totally get that, and that's really sad. But still, #1 on that list, I'm not too sure about that. However, no matter which technology we are using, defending against SQL injection is so easy. There is no excuse for having SQL injection in the first place. If you use OR mapping, then well, you should be safe if you have an up-to-date version of the OR mapper, and we'll talk about that, having an up-to-date version in a bit. And if not, well, the best way to prevent SQL injection is to have prepared statements or parameterized queries, right? So you do not have commands and data in the same string, but you have placeholders for the data and then assign values to the placeholders. And the mechanism then automatically does the escaping for you. So really, no excuse for SQL injection. Really, there isn't. But I also do not see SQL injection as a big as a problem today as it was before. So still #1, but that sounds a bit weird, right? Because it just doesn't happen. I also have some tiny issues with #2, also because it's so high up on the list. It's broken authentication and session management. Now I know session management. I mean, just if you talk about session management, we talk about things that are broken. Because if you read the HTTP specification, then you see there that, and I think it's the second sentence in that specification, that HTTP is a stateless protocol, meaning with HTTP you can't remember anything. However, applications do need to remember something, whether the user is logged in, what kind of items are in the shopping cart, etc. So well, session management was kind of invented. Well, first cookies were invented, then session management was invented, and essentially people found out you can do session management without cookies, but if you do that, you're a host. So okay, you have to use cookies and you have session management together with that. Now there are different, well, risks and associated attack vectors against session management. The most commonly known is session hijacking. The idea is with session management, every session gets a unique name or number, the session ID, most of the time it's called. So usually that session ID is sent to the client in the form of a cookie, and with all subsequent requests, the client sends back that cookie, sends back that session ID. So the application then knows, okay, that's the session ABC123, and yeah, I've stored data about that session, okay, that's that user, and the user has these items in the shopping cart. That's great if the session ID remains a secret, because the session ID is the only thing that identifies the user there. Right? So if the session ID is stolen, and there are several ways of stealing a session ID, then the session is hijacked. So that's the most common attack against sessions. So we need to protect our session IDs as good as possible. So one of the aspects, and this is also covered in one of the other items on the list, is if a session ID is transported unencrypted, because we have a web application that doesn't use HTTPS, anyone can intercept that traffic. So here at the conference, if you're at the conference Wi-Fi, the conference Wi-Fi isn't encrypted. So everything you load or request on the conference Wi-Fi, which uses HTTP, can be seen by other people in the same network as well. HTTPS, not so much of course, but HTTP, yes. So if the session ID is transported via HTTP, then we have a problem, then session hijacking is possible. There are other risks involved, other attacks involved as well. For instance, you can configure your sessions in various ways. One of the aspects of configuring a session is to configure a session timeout, meaning after which amount of inactivity is the session considered, well, discarded or expired. And usually you have this scale with usability on one hand and with security on the other hand. You have the best security if you have a session timeout that's as short as possible, because short session timeout means if someone steals a session ID, the attacker doesn't have that much time to actually use the stolen session ID if the session timeout is set to a low value. On the other hand, that means, if you go to a page, the page takes some time to load because, conference Wi-Fi, a lot of people in the network. You go to another browser tab, do something, you go back, session ID has expired. You have to re-log in, bad usability. On the other hand, great security. So it's kind of hard to get both. So there are several things you can do, but basically session management is something that is provided by the framework we are using. If you use ASP.NET, we have session management there. If you use PHP, there's session management there. I mean, that session management at least tries to use as many best practices as possible. So the session ID is not, and I saw that at an audit recently, a 6-digit number, which is kind of easy to guess, but it's a long string, hard to guess. There are settings to ensure that the session ID is only being transported via HTTPS. There are settings that the session ID is not accessible to JavaScript code. So there are options, well, and usually they are activated by default. So not much can go wrong. The only thing you should consider is that you implement your own additional safeguards. For instance, you could store in the session let's say the user agent. Right? It doesn't mitigate all risks, but if a user is using, let's say, Chrome all the time, and then all of a sudden the user in the same session is using, let's say, Edge, or let's say Internet Explorer. I mean, it's always a bad sign if a user is using Internet Explorer, right? But if suddenly the browser changes, then something may be wrong. So you might actually then, log out the user or flag all the actions that the user is doing from now on. So that's number 2, and it kind of is important, but I think it's pretty high up on the list, because if you look at security issues, especially at security issues, there's one thing that was part of the list in 2003, and has had a top 3 position ever since then. And that's, of course, cross-site scripting. That attack is so old that you would expect, well, nowadays it should be solved, but it isn't. It just isn't. The idea, of course, is that we somehow manage, as an attacker, to inject some content on a page, and that content usually happens to be JavaScript. Or, you know, in the old days, it could also be an object tag that was loading, the young people in the room doesn't know that term, so apologies for that, that was loading a plugin with some content, like, you know, Flash or Java, because many of those plugins have security vulnerabilities in older versions, so that was an easy way to install some interesting software there. Cross-site scripting is still one of the worst attacks to get, because if you have cross-site scripting on a page, not only can the attacker run arbitrary JavaScript code, but also it's almost impossible to defend against other attacks, including cross-site request forgery, which will come 5 points further down in the list. So cross-site scripting really is a big problem. Especially with modern single-page applications, new vectors are opening up, so I find this pretty interesting to mention. Usually when we talk about cross-site scripting, we are talking about type 1 cross-site scripting and type 2 cross-site scripting. Type 1 cross-site scripting is, well, probably the worst of them. Persistent cross-site scripting. So the user sends something, let's say JavaScript, to the server stores it in a database, for instance. Which is fine, because the database doesn't care at all about JavaScript. The problem is that the web application later can read out the data from the database and maybe puts it on a page verbatim without any encoding. So whoever then loads the certain page does execute the malicious JavaScript code. So that's the worst thing to happen. The most common thing to happen is non-persistent or reflective cross-site scripting. The user sends something to the server and the server echoes it back. Typical example, search page. So you have a search field on a page and you search for something, whatever, let's say NDC. And the resulting page usually says your search for NDC yielded, whatever, 100 matches. And that NDC part of the output is something that comes from the user. Now what happens if you do not search for NDC but for script tag and then some code? Well, if it's printed out without any encoding, then you inject the JavaScript code. It's a bit harder to make sure that someone else is then getting that JavaScript code, but there are ways to do that, right? So these are the most important and common versions of cross-site scripting. However, there's an additional one, and the OWASP has created this kind of classification of cross-site scripting. And the first one was not very common until a while back, but nowadays it's getting more and more common, DOM-based cross-site scripting, where everything happens on the client. So the idea is you have a single-page application. The single-page application reads something from the URL, maybe a URL fragment, uses that information and puts it on the page. So no server interaction. Well, but if that fragment, for instance, contains JavaScript code, or if you're using, let's say, AngularJS, and the fragment contains an AngularJS directive, and that directive is then applied to the page, we still have cross-site scripting without the server doing anything, right? So there are a lot of new issues coming up, and therefore it's super important to defend against cross-site scripting. We talk about defending against cross-site scripting in a second, but there's just one thing I need to talk about, and that's the same origin policy. Because the same origin policy is the sole security mechanism JavaScript has. To JavaScript's credit, this security mechanism is available since the inception of JavaScript. So there wasn't even cross-site scripting, but they already kind of had a hunch that something might happen. And it's important to know because it kind of protects us from some attacks. But on the other hand, it makes attacks, if they go through, extremely dangerous. So if you have a page and that page has some inline JavaScript code and is also loading JavaScript code from their own server and then maybe from a CDN. I was using jQuery here as an example, but this could be any JavaScript library. That JavaScript code that's inline and the JavaScript code that's loaded from your own server and the JavaScript code that's loaded from another server, they all run in the same security context. And the security context of the JavaScript code has nothing to do with where the JavaScript code comes from. It only has to do where the JavaScript code is loaded. The JavaScript code is loaded here at example.com port 80 using HTTP, and that's the so-called origin. Origin consisting of protocol, domain, and port. The JavaScript code now runs in the security context of protocol, domain, and port, so it may access anything with these three, well, attributes or values matching the current HTML page. So JavaScript code can, whatever, access cookies set for HTTP example.com on port 80, which is a necessity for it to work. It can also access all the elements on the page because it's the same security context. That's also important because if you load jQuery or AngularJS or React, then you know the frameworks do want to access the current page to do their thing. Yeah, but if you have malicious code injected via cross-site scripting, that code of course runs in the same security context, so it can do anything your own code is doing. And I mean, I have written code that it's considered dangerous, but because it was so buggy. But you know, if you are really creating malicious code and injecting it on that page, it's a big catastrophe. So the same origin policy is both something that's a safeguard, but on the other hand, it makes cross-site scripting even more dangerous. Now, let's talk about protecting against cross-site scripting. In HTML, we have 5 special characters. We have the angle brackets, opening and closing, because they delimit tags. We have the single and double quotes because they delimit attribute values. And we have the the ampersand character for HTML entities. If we have user data and we would like to output it, we have to escape those 5 characters if we are in an HTML context. I mean, technically that's a blacklist, right? A list of 5 forbidden characters. And what you learn in, when you talk about security is that usually blacklists are bad because one missed item in a blacklist, meaning security vulnerability. Better is a whitelist, a list of allowed characters. But this is, I think, the sole exception where a blacklist is good enough in an HTML context. If you output user data in JavaScript, then, well, my first recommendation is try another approach. Seriously, try something different. But if you have to do it, JavaScript has additional special characters. For instance, the backslash. This needs to be escaped as well. But there are other options too. Internet Explorer 8, yes, Internet Explorer 8, the greatest browser ever written. No, seriously, you're laughing, and I'm kind of smiling too. But in retrospect, actually, it was a decent browser. Why? Because it introduced a lot of security features, which first went kind of unnoticed, but were then adapted by most other major browsers. I will not talk about Internet Explorer 9, 10, or 11. These are different kind of beasts. But Internet Explorer 8 introduced, among other things, a built-in cross-site scripting protection. So there was heuristics, and when Internet Explorer thought, okay, this might cross-site scripting, then cross-site scripting was blocked. Sounds like a great idea. But, can we really trust that blocking mechanism? Is it maybe blocking my legit application? So there was an HTTP header, XSS protection, and if you set that to 0, the cross-site scripting protection was turned off. Actually, Google did that the day Internet Explorer 8 was released because they were afraid that Internet Explorer 8 is doing something funny to their search engine. A few weeks later, they put it back on because they found out, well, actually it's a pretty good thing. The cross-site scripting protection is not perfect because they want to avoid false positives at any cost. It's better to let an attack slip through than make an application, a legit application, not work any longer, because then people think the browser is bad. Right? But still, it's a pretty useful feature. It's also implemented now in Chrome and Safari. It's not implemented by default in Firefox, unfortunately. So that's why I often do security tests in Firefox, right? Because there's not the built-in protection. But actually, it's a pretty useful thing. But I mean, truth to be told, it's pretty sad, in my opinion. So the browsers have to come with a protection because we as developers are not good enough to protect against cross-site scripting. That's depressing. It really is. But maybe I have something to turn that depression into enthusiasm. And that is something called Content Security Policy, or CSP in short. It's a W3C standard. Version 2 has been standardized last year. it is supported by all the major browsers. If your interpretation of all the major browsers means current Chrome, current Firefox, current Safari. Is there a browser missing there? Oh, actually, current Edge browser has it as well, but only if you have the creators update for Windows 10. You know, that one that was released in February, March, something like that, April. Well, you know, a few months back. Previous versions of Edge only support an older version of content security policy, which is kind of good enough. The major issue with content security policy is Internet Explorer. Internet Explorer versions 10 and 11, they do support an old version of content security policy, but they only support one feature, and that feature is, I wouldn't say worthless, let's just put it that way. The feature is not in use in the real world, right? But still, great technology. I could talk for hours on this, but I'd just like to show you a quick example that you see how it generally works, and I hope you will be as excited about that as I am. So the idea is this. The server sends an HTTP header, content security policy with dashes in between, and a policy telling the browser where to load data from, where to load resources from, what kind of code to execute. And the browser is then enforcing that, right? So the browser gets this header, whatever, only loads images from that server. And if there are images being loaded from another server, the browser just says, no, I won't. And that can be really interesting. Now, actually, let's have a look at an example here. So I have a page. Here's the page. Excuse me. So that's a page. It has a beautiful image. And it also has an alert window. It says inline. And when I close that window, it says external. Well, because there are two types of JavaScript code on that page. Actually, by the way, I'm a great designer. So you see, we have here beautiful orange bullets. Okay. So let's have a look at the code for that. I happen to have it open. So what we basically have is we have some inline JavaScript here. Then we load an external JavaScript file, but it's it's on the same server. But that doesn't really matter at the moment. And then we have the list here, and we have an inline style for that list. And what we also have is we have two links. One link is just loading the page, and the other link is appending CSP equals 1 to the URL of that page. Now in the controller, so it's an MVC application, in the controller, what we do on that page is we check if CSP equals 1 is in the query string. And if so, we set the content security policy header to a specific policy value. Now, such a policy looks like this. We have a set of so-called directives. These are those things with the dash in between. So the default SRC directive, what it basically does is it provides a list of URLs for, well, everything we load, usually with an SRC attribute. Default SRC is, so to speak, the mother of all directives. We have more specific directives. For instance, image SRC, where to load images from, or script SRC, where to load JavaScript from, or style SRC, where to load style sheets from, font SRC for web fonts, etc., etc., etc. But if you set default SRC, this kind of encompasses most of the other directives. So I could provide a list of origins here, or in later content security policy versions, specific URLs or URL fragments. But what I could, for instance, do is HTTP, whatever, localhost port 1234, and then everything can only be loaded from that server. Now, actually, this sample page here is not running from localhost port 1234, but localhost port I don't even know. So that's not a good idea. What I actually want to do is that everything is loaded from the current domain, the current origin of the current page. And for that, we have a constant. And because it's a constant, it's delimited by single quotes. Single quotes self means, okay, load it from the current origin. If it's not from a current origin, don't load it. Well, if you have a look at the markup again, we see that shouldn't be a problem because the image comes from the current server because a relative path, as does the JavaScript code. So we might expect that with content security policy, the page works exactly as before. Now, let's try this out. So I click on the CSP link, And if you look very closely, bottom left, you see that CSP equals 1 is appended to the URL, okay? So when I click on there, what I get is a pop-up saying external. Wait a minute, wasn't there like inline before? Okay, very weird. Let's have a look what's that about. And then we see, well, the image is still there, but my beautiful orange color is gone too. So the inline pop-up, the inline alert window didn't show up, and the color is gone. Why? Because both of those were inline. Inline style, inline JavaScript code. By default, if you have a content security policy, then inline is disabled. And that's a good thing. Because how does cross-site scripting work? Let's talk specifically about cross-site scripting. Well, someone injects script alert 1. Not possible any longer with content security policy because there is no inline code which we can run. Okay, I'm intrigued. But there's another attack vector. Script src equals http attacker.com/badscript.js. Not possible with content security policy because we're telling the browser only load JavaScript code from our own server. So that attack vector is closed as well. Third attack vector. Script src equals badscript.js. So yes, we can load malicious JavaScript code if it is already residing on the target server. On the other hand, if we as an attacker manage to upload some malicious JavaScript code to a remote server, then cross-site scripting is probably the least of the problem of the owners of that server, right? So technically, with content security policy, we can beat cross-site scripting. I mean, it does come at a certain cost. Disabling inline JavaScript code, for instance, might be cumbersome for some kind of applications. So those of you who have worked with, let's say, ASP.NET Web Forms in the past, or maybe still now, you know that the mechanism behind ASP.NET Web Forms is injecting some inline JavaScript code, which is needed for running the page, especially when you work with forms. Well, this code then doesn't really work very well. Well, it doesn't actually work when you use content security policy. There are ways around that. So we can enable inline JavaScript code again. So what we could do, for instance, is we could add another constant. And I mean, you know, if I was to write a specification, I would say, okay, let's add a constant called inline, which enables inline, because a standard is supposed to be neutral. This standard is not neutral. The constant is not called inline. It's called unsafe-inline. So we do know that it's a bad idea what we are about to do, right? So we know by adding this unsafe constant, yes, inline code is back again, but then on the other hand, a new cross-site scripting attack vector just opened. So yeah, there might be some issues. Content security policy version 2 added new features that we can say, okay, we do not want to allow inline JavaScript code unless the JavaScript code has this SHA hash, right? So if we know we always have the same kind of inline JavaScript code because the framework just emits it, then we calculate the hash and say, okay, if the code has this hash, then we can run it. And it's really hard for an attacker to, you know, write malicious code that happens to have exactly the same SHA 512 hash, if not virtually impossible. So I think it's almost impossible to create a collusion here. So that is an option only available in Content Security Policy version 2. So if you still have support older Edge versions or Internet Explorer, that is not an option for you in those cases. For those browsers, you have to use unsafe inline, right? Or you refactor your application to, well, actually avoid inline styles, inline JavaScript code, which from a performance perspective is a good idea anyway. Again, I could talk for hours about content security policy, and I think you also get the impression that I'm a bit overexcited about this. But still, do consider using that in your applications. I've migrated so many customer applications to content security policy. And it's always, you know, it's always a bit of a struggle, especially if it's a legacy application that does funny stuff with, you know, injecting code in the page. But in the end, you know, you have just an additional, very, very thorough layer of security that helps defend against number 3 on that list. So really, it's a great thing. So please do consider using content security policy to beat cross-site scripting. The next item on the list, number 4, is a bit more, or let's say it's a mixture of 2 items of the previous list. It's called broken access control. And the 2013 list made 2 items out of that because they made a differentiation between accessing data and accessing functions. Well, you know, when you're using an MVC framework like ASP.NET MVC or ASP.NET Core, then basically the URL very often maps to a method or a function on the server. And, you know, some applications are very optimistic, so they think, well, my URLs are secret, right? So no one has kind of gets the idea to go to my website and then does /admin at the end of the URL, or question mark is admin equals true. So while I just do this to create a backdoor in my application, yes, it still happens. I recently found something like this. So access control to all functions must be in place. When you have a form and that form can only be loaded when you are authorized, but when that form is posted back to the server, you just assume, hey, how should someone know that there's a form to post back, so I do not need to authorize the post request? Oh yes, you do. Same thing goes for data. So if you have some secret information, if the only thing secret is the link then, or the URL, maybe it's not good enough. I mean, the OWASP top 10 is a list of risks, and with all risks you have to do risk management and have to decide, okay, do I have to invest resources to mitigate that risk? Take Facebook, for instance. If you go to Facebook, if you upload a picture, a photo, and the photo is not public, right? So only for your friends or even private. Still, that picture gets a URL on a different server, and there is no access control. So if someone guesses that URL, they can just access the picture without any access control. The URLs are so long that it's really, really hard to guess that URL, but still, access control to data is missing there. There are reasons why it's that way, also performance reasons, and so, you know, Facebook does the trade-off. And very often we do the trade-off as well. But still, keep that in mind. Now, when we talk about access control, there's one thing I like to briefly cover, and that's an attack called mass assignment. So this was on GitHub a while back. You know, on GitHub, when you open an issue in the issue tracker, it says this issue was opened 20 minutes ago. This issue was opened in 1001 years, right? And the attack here is called mass assignment or overposting. Now, the idea is this. This was done in Ruby on Rails, but it's also possible in ASP.NET MVC if you use model binding. So let's talk about model binding. Model binding in ASP.NET MVC means you have an HTTP request, let's say a post request, and you know you have some data in the post. Let's say how would this bug entry look like? A title and a text and an author maybe. And so you have well, maybe the author is part of the session. So let's just say title and text. So you send an HTTP post request to the create new entry endpoint, and you have a field called title with I'm Bender from future, and you have a field called description or text, and well, you have the text of the entry. Now what model binding does is you probably have a model class, a bug entry, and the bug entry has public properties like title and text. And model binding looks, oh wait, there is something in the HTTP post that has the same name as that property. Okay, let's assign it. Oh, and then there's another thing that has the same name as the property. Let's assign it. So model binding automatically turns the text-based HTTP post into an instance of our, let's say, bug entry model class. Now, the problem is that that bug entry model class will also have a property called creation date. The form for setting up such an entry does not have a date picker, because in the constructor of that model class, we just set the creation date to the current date. But what if the HTTP post request would also contain a field called creation date equals June 15th, 3018? Well, first the class is instantiated, and then all the attributes and all the members are set. So in the end, we have a bug entry opened on 15th of June 3018, which is exactly in 1001 years. And that's what happened here. Same goes if you add a user to a system and you have a custom user management, and that user has a property is admin, which of course is stupid for various reasons, but let's just assume it, because we all know it happens. Well, if you send is admin alongside the creation HTTP post request, you have a new admin user. Right? If you are using the wizards in current versions of Visual Studio to set up, you know, CRUD views and controllers using Entity Framework, then what these controllers do is they set up those methods for adding a new element in your model class, but they also suggest that you use the exclude or include attribute in order to specifically say, okay, these are the properties I would like to bind, or these are the properties I would not like to bind via model binding. Those properties and those comments are in there for a reason. So if you have a model where not everything should be set by the user, take care that when the user is adding one item in your repository, that not all the properties may be bound. Very, very important. So that's why I put it in here. There is no actual entry for that in the OWASP top 10, but here number 4 is kind of the one that fits best. All right, I'm a developer, so when something goes wrong, whose fault is it? No, not my fault. No. I'm flawless. Management. Yeah, management is good, but management it's always management's fault. But no, in my company, I do a little bit of management, so management is perfect as well. Who is it? Yes, of course, it's the admin. The admin, yeah, exactly. I'm not an admin, so number 5, security misconfiguration. No, that's not my thing. But wait a minute, don't we all do kind of DevOps-y stuff nowadays? Oh, okay, so I am the admin. Ah, damn it. Yeah, so of course, the server, the operating system, they need to be hardened. We have to make sure that error messages are not shown to the user. Stuff like that. So all of this is kind of put into number 5, which kind of is obvious, and if you're lucky, then there is an admin that does take care of that for us. If not, you have to keep that in mind. So rather short point. Number 6 is called sensitive data exposure, which basically means use encryption. Use encryption everywhere. Well, use HTTPS. Let's talk about encryption. So for instance, passwords must be encrypted, right? And we'll see an example for that in a bit. What I also find interesting is use HTTPS. Why? Well, for instance, think about session hijacking. If you use HTTPS throughout, then at no point in time, the session ID is sent unencrypted. So even here, conference Wi-Fi, we cannot access the session ID from someone else. But what happens if, let's say our website, ndcoslo.com, let's just assume that, is using HTTPS. But what happens if I enter ndcoslo.com in the address bar of my browser and hit enter? Well, then the browser sends an HTTP request, and then the server maybe does some URL rewriting or redirection, and then goes to HTTPS. But that first request is unencrypted. So if I happen to have a session ID that's also sent via unencrypted communication channels, and there are ways to avoid this, but still, then, well, we have one unencrypted connection. But there are good news. There's something called strict HTTP transport security, and that's also a mechanism supported by current browsers that forces the browser to remember to only use HTTPS to access a certain site, even if the user was entering an HTTP URL. And the amazing thing there is that modern browsers come with a preload list. Okay, it takes Google Chrome a while to actually display that. Okay, let me increase the font size. It's a very long list. It's about 2.5 megabytes of JSON, which is then formatted here. And that's the list of Chrome. And if you scroll down there a little, once the browser reacts again, we'll see that the list contains a lot of domains. Of course, domains from Google, but also domains from private people, from organizations, from almost anyone. Yeah, once it's loading. Is it loading? Oh, well. Okay. So I'm in the middle somewhere. So London.dating. I have no affiliation with that site, but yeah. If you go to London.dating and your significant other is in the same open Wi-Fi, then they won't know. Okay? Maybe, maybe not. Yeah, but so it's a pretty fascinating idea. And why are there these kind of private or let's say non-Google domains in that list? Well, that's because no, not because of that. Because of that, you can add your domain to that list. So there's a mechanism. Your domain has to send out certain headers, but basically you can add yourself to that list, which I think is pretty useful if you use HTTPS throughout. There might be reasons to avoid using HTTPS throughout. So for instance, if you have older clients connecting to your application, or if you are afraid of performance issues, but basically nowadays we should use HTTPS throughout. And with HTTP2, from a performance point of view, HTTPS is not significantly slower. All right, number 7, and number 7 sounds a bit weird. Insufficient attack protection. Okay, well, you know, if I have an application and I have a security incident, yes, I did have insufficient attack protection. So what is this point all about? Now, according to the OWASP, the idea is if someone is attacking us, we should find out. So if there are automated attacks, if you get a lot of requests from maybe even the same IP address of the same type, we should have software in place or mechanism in place that finds that out. And if we are really good, we should also have software in place that finds out if someone does a manual attack. But well, I would say at least the second point is kind of wishful thinking. But of course, web application firewalls and network analysis tools, they can help us a little bit and also then decrease the attack surface. And another thing is quickly install patches, right? Yeah, I know. Why change our running system? I recently went to a dentist, and the dentist had Windows XP with a list of patches that have not been installed yet. So like, okay, I know what I will do. I'll go to another dentist. So I went to another dentist, and the other dentist didn't have a computer at all, so I felt very comfortable, actually. But seriously, quickly installing patches is important. You all heard, I guess, about WannaCry, which kind of hit worldwide. And what WannaCry was doing, they were abusing a security vulnerability in Windows that was, I think, closed in March. The attack was in May, so, well, 2 months passed without any patches being installed. So I come from Germany, and we have one big train provider, some smaller ones, but one big train provider. It's like the NSB here. And these were their displays, actually. So, you know, the displays on all the stations nationwide, right? And I was really angry because I couldn't even see where the trains were going because of the ransomware thing being displayed nationwide, okay? So a centralized IT is a great thing because then attacks are also system-wide. All right, so yes, quickly install patches or tell the admin to do, super important. All right, the next thing is cross-site request forgery. And cross-site request forgery is an interesting beast because cross-site request forgery is only on number 8. And it's so dangerous. So I think most of you are aware of cross-site request forgery, but just to quickly reiterate what's happening there. I kind of prompt one of our victims. So let's say I'm the attacker and you're the victims. I prompt you to go to my website, maybe because, hey, the slides will be up there on the website. I guess they will be on the NDC website. If not, you know, go to Twitter or send me an email, and I'll be more than happy to provide you with the slides. But anyway, so I prompt you to go to my website, right? And on my website, what you're getting is some JavaScript code, and that JavaScript code prompts your browser to send an HTTP request to another site. Now, the other site might be your router at home, and the HTTP request you're sending to the router is change the WPA2 key. Because changing the WPA2 key in a router usually just means you send a post request with the new key. You don't need the old key, right? How do I know which router you have? Well, I just do the math and just check, okay, what's the most common router? in Norway, sold in Norway, and since you are all my victims, a number of you will have that router. Next thing, how do I know what the address of your router is? Well, I just, go to the store, buy the router, and then see what's the default IP address. Then the only thing missing is I need to kind of social engineer you into logging into that router right before going to my website and being in the same browser. But, well, since I'm attacking all of you, maybe one or two will, be so cooperative and allow me to change your WPA2 key. Now, the only thing I need to find out is where you live, because then I have free Wi-Fi, because I'm the only one who knows the new WPA2 key. But that's a problem I might be solving as well. So that's basically cross-site request forgery in short. And the OWASP says, well, cross-site request forgery is so far back in the list because frameworks have protection against cross-site request forgery. Okay. Why do I find cross-site request forgery so often? Maybe wrong framework? No, you have to activate that feature, and still, you have to do it. I mean, with ASP.NET MVC, it's rather simple. You have an HTML helper that sends out a hidden form field with a token. Sometimes it's also called nonce. I know in the UK that word is kind of offensive, but it stands for number used once, but let's just say token. And then you have an attribute in the controller that checks whether the token is there. So everyone here, if the router implemented that, everyone there in your routers, you would have a different token. So I cannot forge that HTTP request to change the WPA2 key because I do not know your token. I bought the same router, I got a specific token, but you got the different token. Right? So that protects against cross-site request forgery. So protection is easy, but you have to do it. Still, I don't understand why this is on number 8, and let's say SQL injection is at number 1. So yeah, that's I take I have some issues with that here. There are other aspects here. So for instance, clickjacking, which is an advanced attack where I do not lure you to my website and then do some crazy redirection, but I hide the shut down your router page in an iframe on my page. And when you click on my page on a link, you think that gives you the download of the slides here. You actually do click on the shut down the router button of your router, which is loaded in an iframe. So really, really crazy, crazy version of cross-site request forgery. And against that, you can only defend if you prevent your pages being loaded in a frame or iframe. But basically, number 8 should be much higher on that list. All right, number 9, we're almost done. Using components with known vulnerabilities. Yeah, that's a risk, but do you remember the image from before? I mean, seriously, that's kind of the same thing. Right? So yeah, do check whether the framework you're using has security issues. I mean, even ASP.NET MVC had a security issue that was fixed by a patch, so follow that. And I mean, now with ASP.NET Core and the rapid set of updates, I know it can be a pain, but on the other hand, issues get fixed quickly. And, well, almost finally, number 10, underprotected APIs. I mean, English is not my first language, or not my second language even, but underprotected, I've never heard this. But what this is kind of saying is that nowadays we have a lot of APIs that actually provide the functionality for applications, especially when we do single-page applications. These APIs need to be protected as well. So if those APIs write to a database, then yeah, SQL injection might still be a thing. But, well, I told you I don't. If these APIs return something, maybe data that is sent to the API might be cross-site scripting. So if we just load the API in a browser, we can execute JavaScript code. So all these protections we discussed and talked about, they also need to be used and in place for the APIs our applications have. And that's basically the top 10 list. And since we still have a few minutes left, I'd like to show you one more thing. One attack that doesn't really fit here, but shows that even after 20 years of JavaScript and after 25 years or even longer of HTML, there's still kind of new attacks that are possible. So I brought one of those attacks for you. And what's happening here is this. I have a page here. It's called page 1. Yeah, I know, very creative. Just imagine that would be, let's say, Instagram, because I think Instagram was the first victim of that attack. So when you set up an account for Instagram, on your profile page, you can also put a link to your homepage, right? To a page you control. So I would like to click on that link. Now that link to the homepage is titled page 2, and if you look at the lower left corner, maybe you can see that it's going to no opener to HTML. So it's opening up another HTML page, and actually it's opening up that HTML page in a new browser tab. Because if you have a look at the source code, we're using target equals blank, okay? So nothing fishy going on here. I am on page 1, and I click here on the link to page 2. Now, here in my setup, it's the same server, but it also could be an external server. So in opening up page 2, so I'm here on page 2, I read all the fascinating information on page 2, and once I'm done, I hit Control W to close the browser tab. That's what I'm always doing, right? So I'm opening up a new tab, do some reading, and then I go back. What happens if I go back? And I won't close actually that page, I will just go back to that tab here, okay? What do you expect to see? Well, you certainly do not expect to see bogus page 1 here. But why is here bogus page 1? Now, let's have a look at the source code of the other page. And what the other page does is, it is accessing a JavaScript API called window.opener. That's around since 1995, which gives us, back then, you know, we still had pop-ups, and with that it allowed the pop-up to access the opening window. Now, thanks to the same origin policy, we have very limited access to that opening window, especially if the target page is on a different domain. But what we can access is the window object, and thanks to the window object, of course, the location. So we can redirect the original tab. And what's that? Of course, phishing. So you go to Instagram, you set up a profile, you link to your homepage, and on your homepage you access the opener, and then you redirect from Instagram to a page that looks exactly like Instagram, but just wants to double check your password for Instagram for security reasons, right? Typical phishing. Now, why am I telling you this? Because Instagram fixed that. But, well, you have to fix that as well. And actually, fixing that is pretty easy once you know why. So whenever you have an external link to a page you do not control, you have to add rel equals no opener. And that prevents that the target page has access to the opener. Unless you are using Firefox prior to version 52. We now have, I think, 53. But up to Firefox 51, no opener wasn't implemented. So for Firefox, you had to add no referrer. And then you are fixing that for Firefox as well. This kind of attack is hard to put in the risk list of the OWASP top 10. Because, I mean, what's the risk here? That there's a weird browser feature that allows users to redirect a page if that page opened your page in a new tab. I don't know, maybe insufficient attack protection or something. You can put it one of these very general terms. But yeah, you see, there are always new attacks. So thinking about web application security, frequently reading up on web application security, staying up to date with web application security is so paramount these days. And therefore, in my opinion, the OWASP top 10 list is still relevant today because it shows us all the common risks, but of course it's not complete in a way that all risks and all attacks are covered by that. And with that, I hope you stay safe, your website stays safe, and I thank you for attending. Thank you very much. Thank you.